Alright, so lifters and tappets. We pretty much already talked about all this, so we'll go through it pretty quickly. So there's our flat tappet design, that's our old design. Here's our roller tappet or roller lifter design. Again, that's going to be our newer engines. Basic thing is on the flat tappet, if we're doing any kind of work on this engine, generally cam and lifters all get replaced. So we replace the cam, we replace all the lifters, because these do get considerable wear on them. If we have the roller design, most of the time they're going to be reusable. So we're still going to have to inspect them, but generally they're reusable. I have seen some roller engines where the cam lobes have started to become flattened or the roller lifter's been damaged. You don't see that very often though. It's typically going to be associated with lack of maintenance. The other place I've seen it more is how many valves do we say each lobe normally operates? One, right? One lobe operates one valve. There are some engines where one lobe operates multiple valves. Well, think about it. If this one lobe has to operate multiple valves and overcome multiple valve springs, what did we just do to the pressure on this lobe? We doubled it, right? If we double the pressure on this lobe, what are we going to do to wear and tear on that lobe? We're going to double it, right? So we're going to be more likely to see issues. And you can also kind of see here what I was talking about in terms of lobe design. With that roller tappet, we can have a much more extreme or much more aggressive cam lobe. So we get that valve open fully much faster, we sort of keep it fully open longer, and then we close it much faster. And so that's going to give us better flow characteristics overall. So another difference between the two, when we had the flat tappet lifter, we said this thing had to rotate to get nice even wear, right? If it stopped rotating, we were pretty much done for. On a roller lifter, because we do have that big roller wheel, this thing has to stay in perfect alignment with the lobe. So there's going to be something that actually keeps this lifter from rotating now. And so this is a pretty common design on this engine. On the tops of the lifters, they have some flat spots. We have these little links that go in between. A lot of times they call those dog bones that fit in between the lifters. And then there's a little plate that holds that in place. So that just keeps the lifters from rotating, so the roller wheel maintains alignment with the cam lobe. So flat tappet lifter's got to spin, roller lifter, it can't spin. So this would be a flat tappet lifter, and this would be what we consider a solid lifter. So we have some parts and pieces inside here, but none of this stuff moves. So this acts as just basically a solid hunk of metal. So again, in this case, we're going to have to do some sort of valve lash or valve clearance adjustment. This one here is a hydraulic lifter, and this one also happens to be a roller lifter. So it has the roller wheel on the bottom. So now you see we have some more parts and pieces inside. So the main thing we have is that plunger or piston inside of it. That plunger or piston can move up and down based on the low pressure and based on the clearance in the system. So that creates that automatic adjustment. On this, if we have to do any sort of initial adjustment, what we're doing is we're centering that plunger. So what we're going to do is we're going to basically put some tension on this with the push rod to actually center that plunger inside of its bore. What that allows us to do is if we need more clearance, the plunger can drop down and allow more clearance. If we need less clearance, the plunger can rise up and create less clearance. So it allows it to adjust both ways. If we just put this in here like this, with the plunger all the way at the top, can we take up any clearance? No, we can make more, but we can never take up any, right? So when we do our initial adjustment, we're centering that plunger in its bore. And we'll see that in the video as well, in terms of how we do that. But again, that would only be during initial assembly. After that, we should never have to touch it. And this one, like I said, is hydraulic roller. The other one was solid mechanical, solid flat tappet. Could I have a roller lifter that's a solid or mechanical style? Yes. Yeah. Could I have a flat tappet that's hydraulic? So it's two separate things. So we could have flat tappet or roller, and solid or hydraulic. We can have any combination of those. So it's sort of two distinct aspects of the lifter.